Today we are going to discuss the halogenoalkanes or haloalkanes. First, we'll see what are the reactions which are used to prepare the haloalkanes, and then we'll move on to the reactions of haloalkanes. If you look at the haloalkanes or halogenoalkanes, they are the organic compounds which, as their name tells us, contain halogen. Their general formula was CnH2n plus 1. Hydrogen number, carbon number, double plus 1, and then X. X means halogen. Any halogen, which could be fluorine, chlorine, bromine, iodine, or astatine. Their functional group is X or halogen. We did their naming, we did the isomerism in their different types. They undergo structural isomerism in chain and position. They have no functional group isomerism with any other functional group. And the third one, stereoisomerism, they could have the cis trans if they have the double bond, an extra functional group along with haloalkanes. And optical isomerism, yes, they do have, provided they contain an optical, an a chiral center, right? Okay, today we are going to see how they are prepared. If you look at the preparation, most of the reactions for their preparations we have already done. Once I'll write the headings, you will understand. You remember they were prepared from alkanes by free radical substitution. By free radical substitution. When alkanes under the sunlight, for example, methane reacts with a chlorine, this reaction we have already done, gives chloromethane plus HCl. So this is the one of the way of preparing the haloalkanes. Dusra, they were also prepared from alkenes. There were two reactions which alkenes undergoing to prepare these haloalkanes. If you remember, both of these reactions were the examples of addition reaction of alkenes. One the alkenes, for example, when ethene reacts with the HX, mean HCl, HBr, etc., and the other one when ethene reacts with Br2 or Cl2, etc. Right? So in both these cases, we have the products in the form of haloalkanes. In this case, CH3, CH2Cl, and in this case, CH3, CH2Br. Sorry, CH2, CH2Br. Okay. So these are the method of preparation. Now come to the reactions of haloalkanes. If you look at the reactions of haloalkanes, before I go for the reactions now, I would like to tell you one thing. That if I, for example, write a general symbol for an haloalkane, like this, it's Cl. We know that there is electronegativity difference between carbon and chlorine. CH2 here. So, okay, I'm going to erase it and rewrite it. It is CH2Br and CH2Br. Okay, so if you look at the reactions of haloalkanes, Bacho, one thing, first time that comes, before this we have alkanes and alkenes. Both alkanes and alkenes were non-polar. They did not have any single bond where there's electronegativity difference. Hence, they were non-polar. But in this case, if you look at the haloalkanes, the first time we have seen the difference in electronegativity between these two atoms, and as a result, this is a polar, or this molecule is a dipole now, right? So once you have the polar bonds, now the thing which I told you previously, now you can think of the heterolytic fission taking place, the electrophiles, the nucleophiles. So all that stuff is going to come in this part now, right? Because before this, in reactions of alkanes and alkenes, they were non-polar. So they were not having any kind of heterolytic fissions. So no electrophiles, no nucleophiles, right? At max, there was free radicals in alkanes. Now, one thing. Secondly, when haloalkanes react, in all of their reactions, they have to get rid of their chlorine, because all the attack that takes place on this carbon, and it is positively charged, right? It's an electrophile, or it's a carbocation kind of. So all the attack takes place here, and it has to break its bond. And the polar bond, I always tell you, are more reactive, have the more reactivity. So this is a bond they are going to break first of all, this one. Whenever nucleophile comes in. Because positive है तो nucleophile ही attack करेगा. So in all of their reactions, the product will be kind of like this. R, C, H, H. If it's a substitution, for example, so nucleophile comes here. Instead of Cl, and Cl when lost, it also becomes a nucleophile. So most of the, not all of the reactions, most of the reactions or major part of the reaction follow this procedure. That nucleophile will come in and take the place of Cl. Therefore, this reaction is known as substitution, which is taking place by the attack of nucleophiles. So what we will call it? Nucleophilic substitution. On the other hand, free radical substitution हो रही थी alkane में. So nucleophilic substitution होगी. Now, well, let me tell you, for example, मैं example से समझाता हूँ. If इस R की जगह, let me take CH3. Okay? So if I have CH3, CH2, and then Cl. This is a haloalkane. You call it chloroethane. Now listen, what I'm saying, okay, if you react it, let's say, with NaOH aqueous. This is what sodium hydroxide dissolved in water, right? And your condition is HUR. Whenever I write HUR, you have to write a full word, heat under reflux. I told you the other day what is the meaning of reflux. When the Liebig condenser fitted on a vertical position to stop the escape of the vapors. Now, this is sodium hydroxide aqueous. The nucleophile of NaOH aqueous will come and take the place of Cl. That's the whole reaction we are having in haloalkane. इस Cl की जगह सोडियम हाइड्रोक्साइड में जो भी न्यूक्लियोफाइल है वो आएगा और Cl की जगह ले लेगा. This is what I said. General reaction. अब न्यूक्लियोफाइल कैसे होती है ना, अगर वो मेटल हटा दें तो जो पीछे बच जाएगा वो न्यूक्लियोफाइल होगा. अगर कंपाउंड में मेटल नहीं है, वाटर है, तो जैसे वाटर है और एनी अदर कंपाउंड व्हिच डज नॉट कंटेन मेटल, तो उसका H हटा दें तो बाकी जो भी बच जाता है वो न्यूक्लियोफाइल है. बट एट दिस मोमेंट जस्ट think of NaOH. Any metal in this? So just get rid of Na. What is left behind? So, yeah, so OH negative is the nucleophile. Yes, so the product will be straightforwardly CH3, CH2, and then OH. An alcohol plus, just 1 minute, plus NaCl. आप तो फुल फॉर्म में इक्वेशन लिखिए ना. आप इस तरह लिखेंगे, फॉर एग्जांपल, लेट मी एक्सप्लेन इट. आप इस तरह लिखेंगे कि CH3, CH2, Cl plus NaOH aqueous, heat under reflux, heat under reflux, so it becomes CH3, CH2, OH plus NaCl. So you will write like this. Okay? Nucleophile is the one, please pay attention. Pay attention. Nucleophile is the one that is having a lone pair of electron, okay, or negatively charged. So that's why I told you in NaOH, if you split it into the two parts and get rid of Na, metals always get a positive charge. So whatever left behind is going to have a negative charge and lone pair of electron, right? So that's why I told you a shortcut to identify a nucleophile. Otherwise, a nucleophile is a species that contains a lone pair of electrons. Mostly 99% is a negatively charged substance, but it could have a neutral as well, right? Okay, so, but I'm just writing it in this form. You will write this equation like this. So HUR, heat under reflux, okay? If you react it with, pay attention, KOH aqueous, again heat under reflux. What do you think about it? No, this, the Na, that was with OH, that is combining with Cl to make NaCl. उसमें तो क्योंकि और कोई आया नहीं था, तो न्यूक्लियोफाइल ही बन गया वो भी. Okay, NaOH, KOH aqueous का, what is the nucleophile? OH, that is again going to take the place of Cl. Nucleophilic substitution plus KCl. So ethanol plus KCl. Again, if I react it, okay, I apologize. Okay, thank you. For example, NaCN, the next is NaCN, but you call it NaCN alcoholic or ethanolic. So please, when you dissolve something in water, you call it aqueous. So when you dissolve something in alcohol, you call it alcoholic, right? So if you specify the alcohol, that it's ethanol, so you call it ethanolic. So it's the same thing. You can also write it NaCN alcoholic or ethanolic. Again, heat under reflux. You have to heat it. Again, its nucleophile is what? If you get rid of Na, what is Cn? And that Cn is going to come and take the place of Cl. Yes, now it is sodium cyanide. Plus क्या बन जाएगा? NaCl. Now, one thing which you must notice in this particular case, chloroethane, when undergoes with sodium hydroxide, ethanol is formed. When it reacts with potassium hydroxide, ethanol is formed. When it reacts with nitrile, KCN, what is formed? The function group I told you that this is not in the A or in AS organic, but one odd time the product is going to be formed. So that is the point. Nitrile, right? Very, very rightly identified. And one more thing which I want you to notice, okay, how many carbon in the reactant? Chloroethane contains how many carbon? But the nitrile has how many carbon? 3. So here is the product contains more number of carbon atoms. So length of carbon chain very, very rarely increases in the organic reactions, right? There are a couple of reactions. One is clarification and one is this, where the length of carbon chain increases in the product. For example, in the reactant now has 2 carbon and the product has 3 carbon. If I write the name of this compound, so it is propane nitrile. So please understand this, क्योंकि ये एग्जामिनर इस पे बहुत सवाल पूछते हैं कि whenever the length of carbon chain increasing, so there must be nitrile somewhere. Yes, go ahead. Nitrile, Le, yeah. Similarly, if I react it with KCN alcoholic, heat under reflux, what will be the product? Again, these all reactions are nucleophilic substitution. The substitution which is taking place by the attack of nucleophile. All these reactions are nucleophilic substitution. I can write in, okay, what about this? CH3, now again, KCN alcoholic, when it could be ethanolic as well. So the CN will come and take the place of, so same product, propane nitrile plus KCl. Yes, you have to memorize it. Okay, which solvent. Now you two are soon going out of the room, okay? I told you. So KCN alcoholic mean when KCN is dissolved in alcohol. At times, when you dissolve a solute in different solvent, they have a different nature. I'll explain in a while. Because we wanted a nucleophile, right? So you dissolve it in alcohol. In water, they may have a different type of products. So, for example, I'm going to explain it in a while. The same sodium hydroxide, when dissolved in different solvent, what happens? Now, at this point, again, there is the length of carbon chain increased. How many carbons formed? 1, 2, 3. So it's a propane nitrile from chloroethane, right? Okay, now one more thing here. If I take sodium hydroxide, now you have to please listen carefully. If I have to take sodium hydroxide, this is also answer to your question. If I take sodium hydroxide again, just like I did here, but now I'm not going to dissolve it in water. I'm going to change the solvent. Now I'm going to dissolve it in alcohol. So it is ethanolic, right? This is sodium hydroxide, ethanolic or alcoholic, and the condition is HUR. Same condition, heat under reflux. Now an entirely different reaction is going to happen. Now there is no nucleophile and coming in to make substitute the Cl, right? Now what happens in this case, if I explain it like this, here is the Cl. ना इसी का मैं यहाँ structure बना रहा हूँ बच्चों. This is chloroethane, na? Please pay attention. In this reaction, actually, I'm not going into the detail because वो H positive आता है और इस OH negative आता है और इस H positive को ले जाता है. And similarly, this Cl also goes away along with this H. So in this particular case, as the mechanism is not in the syllabus, so I'm just trying to maneuver around. Explain भी हो जाए और मुझे आपको detail भी ना बतानी हो. So in this case, when NaOH is dissolved in alcohol, it's not simply Cl replaced. In this case, Cl from one carbon and H not from the same carbon, from the neighbor carbon. Please mind this difference. From the neighbor carbon, H is lost. And these two, when they go away, so they make, yes, no, they make these two bonds. Yes, double bond between carbon atoms. So one of the product which I'll get is what? Is ethane, right? And the other, these two, H and Cl, actually they don't go on its own. The Na is going to take the Cl, combined with Cl, and OH is not going to take the place of Cl. In this case, H is going to react with HOH. So it's a kind of base thing. But as I'm saying, मैं उस detail में नहीं जा रहा because that is not part of the syllabus that you understand कि OH यहाँ as a base act कर रहा है, वहाँ as a nucleophile act कर रहा था. But here, what you need to understand is when you change the solvent, the entire nature of the reaction changed. Instead of happening substitution, elimination is happening. Elimination होती है कि जब एक molecule का some part has been lost or eliminated. Now, if you look at that haloalkane clearly and the product ethene that is formed, you see in these two molecules, what is the difference? The difference is it has lost its some part. Which part? H and Cl. So other product will be NaCl plus water. So entirely different type of reaction happens. And now you understand why we choose the solvent differently, because it entirely changes the nature of that solute, right? So it is very important. Exam mein jab ye question aata hai, so what the kids do, they write NaOH. So once you write NaOH, so that's completely incomplete information. Because NaOH, what kind of NaOH? Because if NaOH is dissolved in water, an entirely different reaction known as nucleophilic substitution taking place. When NaOH is dissolved in alcohol, an entirely different reaction known as elimination is taking place. So you have to clearly identify. And same is the case with if you take instead of KOH ethanolic. If I dissolve it, KOH, alcoholic ethanolic is the same thing, okay? Heat under reflux. What is the product? The NaOH and KOH. When dissolved in alcohol, they give elimination reaction. When dissolved in water, both of them are giving nucleophilic substitution reaction. In this case, again, what is the product? Product is going to be ethene plus KCl plus water. Okay, so it is ethene plus KCl plus water. In other case, they ask you the byproducts. Okay, so please understand, when NaOH is there, the byproduct is only KCl. When alcoholic is there, the byproducts are KCl and water, right? So that type of reaction is known as elimination or dehydrohalogenation. What is the other name? Dehydrohalogenation. D matlab removal, hydrogen, dehydrohalogenation, yani removal of hydrogen and halogen from a molecule, जिसे हम elimination कहते हैं, right? So this, and now if I categorize them, the first four reactions, 1, 2, 3, 4, they were known as nucleophilic substitution. The last two reactions which I explained, they are dehydration or elimination. But luckily, haloalkane ke do hi reactions. They undergo only two type of reactions. These are, just hold on, hold your horses. So this is nucleophilic substitution. SN mean nucleophilic substitution. 2 minutes. बोला just 2 minutes. SN का मतलब क्या है, ये उल्टा मैंने इसका लिखा हुआ है. SN प्लीज लिख लीजिए. These four reactions are SN, mean nucleophilic substitution, and the top two reactions are elimination. Alcoholic वाले. फिर वो या पूरी बात करेंगे. KOH NaOH कोई चीज नहीं है. KOH NaOH alcoholic और KOH NaOH aqueous. Elimination or dehydrohalogenation. So haloalkanes have only these two types of reactions, right? और अब जो हर group में, you know, we have to undergo and we have to go into the detail of one of the reactions. जैसे alkane में we had 3 reactions and we had the mechanism of only substitution. Similarly, in alkenes we have 4 type of reactions: combustion, addition, oxidation, and polymerization. And we had the mechanism of only addition. Over here, in the next class, we are going to discuss the mechanism of substitution reaction. Right? That's all from my side for today. Thank you. Thank you very much.